amplitude modulation. Now there are up to now we have discussed about the modulation and need for the modulation. Now the first type of modulation is the amplitude modulation. The definition of amplitude modulation is it is a type of modulation, or we can say the amplitude modulation is the type of modulation where the amplitude signal strength of the carrier signal is varied in accordance with the amplitude of the message signal. Of the message signal. Of the message signal. So the amplitude modulation is a type of modulation where the amplitude of the carrier signal is varied in accordance with the amplitude of the message signal. We can also define the amplitude modulation in another way, or we can say a type of modulation. A type of modulation we can say type modulation where the information or a message signal is transmitted over a carrier wave by varying its amplitude in accordance with the amplitude of the message signal. In accordance with the amplitude of the message signal. Now let's discuss about the mathematical expression of amplitude modulation. So here the mathematical expression M. Let us consider a sinusoidal signal, sinusoidal message signal, that is MT message signal, sinusoidal message signal. MT is equal to AM cos omega MT. where AM is amplitude of message signal, omega m is the frequency of message signal. Frequency of message signal. So the message signal will look like this. Here we have a message signal, right? So we have an amplitude AM and a frequency omega m. Now consider a sinusoidal carrier signal. Now consider a sinusoidal carrier signal, which is represented as T equal to AC cos omega CT. Where AC is amplitude of carrier signal and omega C is the frequency of carrier signal. Now using the above expression for a message of message and carrier signal, we can create a new mathematical expression. So let's give this equation 1, name as equation 1, and the CT is equation 2. So using the above expression, for message signal and carrier signal, we can drive a new mathematical equation. Drive a new mathematical expression for complete modulated waves. For the complete modulated wave. Now we have amplitude modulated wave, and let's amplitude modulated wave the amplitude modulated wave or signal, let's say, is A, is given as A is equal to B, and let's say this is the equation 3. Now the carrier signal here, the carrier signal will look like, if we draw the carrier signal, it will look like this. carrier signal. We have a carrier amplitude AC and frequency omega c, and generally the frequency of carrier signal is greater than frequency of match signal. So we have a match signal and this is a carrier signal, which has more greater frequency than the match signal. So the amplitude modulation signal is given as A is equal to AC plus MT, and which is equation 3. Now put the equation MT value from equation 1 3, then we get A is equal to AC plus AM cos omega, and let's say this is the equation 4. Now the instantaneous value of the AM signal, signal can be given as T is equal to A cos omega, and putting the value of A equation 4 into equation 5, we get ST is equal to AC AM cos omega MT cos omega CT. Now take out the value of and then it can be written as AM AC cos omega MT cos omega CT. This is a value you can say we have the general equation of AM modulated signal. Generalized equation for AM modulated wave. So it can be also written as, in simple form, this is a general expression for of amplitude modulated signal. It can be where AM by AC can be written as equal to mu, or it is also called a modulation index. So the modulation index describes the how the amplitude of the carrier, it describes how the amplitude of the carrier signal and message signal affects the amplitude of AM wave or AM signal. So we can rewrite the above equation. ST is equal to AC 1 plus mu modulation index into cos omega CT, and is a generalized form of modulation index. So the modulated signal is look like this. You can draw the modulated signal. It will modulated AM signal. This the modulated AM signal. Here we have amplitude AM plus AC, AM minus AC, and then the minimum amplitude. Here we get a minimum amplitude, the region. Here we get a minimum amplitude, and the region here we get a maximum amplitude, and this, the blue line, is called the envelope of the modulated signal. It's called the envelope of the modulated signal, and the amplitude, maximum amplitude, and the minimum amplitude, right? And is the amplitude modulated signal. Now we have modulation index, and as we discussed, the modulation index is basically AM by AC, and it describes how the amplitude of the carrier signal and the message signal affects the amplitude of AM wave. The modulation index can be either greater than 1 or equal to 1 or less than 1. Now if the modulation index, if the value of modulation index is equal to, it is called a perfect modulation. It's called perfect modulation, and it occurs when amplitude of the message signal is equal to the amplitude of carrier signal. And the advantage of perfect modulation is that in perfect modulation there is no distortion of the signal, so it causes no distortion of, and the modulation index, and it has a modulation depth of 100%. So the modulation depth of 100%. Now we have a second term, that is a modulation, and the second case is when the modulation index value is less than 1. So it is a modulation index value less than 1. So it is also called under modulation. I have mu is less than 1. It is called modulation. Perfect modulation look like this. The perfect modulation. Perfect modulation look like this. In perfect modulation, the minimum value is equal to 0. Now, in case of under modulation, and it occurs when AM is less than the modulation depth is less than, in this case the modulation depth is less than less than 100%. And the advantage of under modulation is that there is no distortion of the signal, no distortion of signal. Why? Because the carrier level falls above the 0, because the carrier level never fall above 0. So it look like this. We have under modulated graph of under modulation. Now the third case is when we have a modulation index greater than 1, which is called over modulation, and it occurs when AM is AC, and it causes a severe distortion of the signal. Generally we avoid over modulation case. So in over modulation, the severe distortion of the wave of the massive signals occurs. So the signal will look like this. This is a case for, and this is a over modulation case, and in the severe